Okay, our battery is essentially set up. The last thing we're going to do is set up the little lightning bolt that is going to jump from the battery to the character. Now, this requires a few things. One, it requires a lightning bolt, obviously. Now, the good news is that in a previous video, we migrated one over from the Content Examples project. So let's find that real quick. And there it is, P electricity arc. I'm going to open that up in Cascade. And I know that there are some changes we will want to make for this. This effect was created for a very specific environment, and which may not fit well with our current environment, so we should expect to have to make changes. Also, it was built with its own, we'll call it hard-coded source and target, so that basically we are, inside the particle system itself, we're saying, I want you to start from this location and end at this other location. And that's fine, but we're going to take the target and actually change the way that works. So grab your target node, excuse me, and we'll take the target method and set this to user set, which really just means we'll be able to update this in our blueprint. So that's going to be important. We're also going to be making some artistic changes, but I'd rather get this working in the level before we do that. So we can just go ahead and click save here. Let's jump over to battery pickup. We'll go into the event graph. Now, we have our own event for this that we created in code, right?
Right. There's the onPickedUp event. You can basically add on some extra behavior here in the blueprint because it's a blueprint native event.
Okay, awesome. There it is. Now, does this have any behavior coded into it that we need to know of?
It does. So there's some behavior we already set up in code so that battery will destroy itself at the end.
Yeah. If anytime that I know that there's a parent function or some functionality already in the code event, I'll go ahead and just create this and have it waiting in the wings, knowing that I need to make sure that's hooked up before I go home for the night. So at this point, we have just picked up the battery. Let's go ahead and spawn our lightning bolt. So we'll drag a wire out and we'll say spawn emitter attached. By spawning this attached, the source of the lightning bolt will automatically, actually, you know what? Let me double check something. It may not. Let's go to our source. I'm going to set the source method to emitter. That means this will always, the lightning bolt will always start at the location of the particle system itself, and it's going to stay there. It's going to always stay bound to wherever the emitter is. By spawning this emitter attached, the particle system will always be attached to the battery. This means that, like, if we pick up the battery and our little lightning bolt starts to strike our character for 1.5 seconds, and then we were to punt the battery across the room,
which has happened.
Yeah, the lightning bolt will stay attached. It'll just get really long, which is cool. So we'll use that. Now we need to know what we're attaching to, and to get access to that, we're going to show inherited variables. And let's see, I think under pickup we should be able to find the pickup mesh.
Yes.
And we'll just attach that right to the attach component. So boom, this will automatically be bound to the pickup mesh. It's probably worth mentioning, if we go over to components, take a look at where the pivot for this mesh is, because that's going to be where this gets spawned and where it'll be attached. In our case, we're very lucky because it's right at the tip of the battery. If you wanted this to be someplace else on, like, say you had a different mesh, it would probably be worth your time to either move your pivot on your mesh itself, or you might have to create like some sort of a manual offset. We're not going to worry about that. Okay, so we've got that. We don't have to update the location. We don't have to update the rotation. We're going to take the location type and set it to snap to target. So that means it'll go right to that pivot point. And auto destroys on, so that should be good to go. Now, this is where things start to get fun. When you tell the target for a beam to be at a specific location, like let's say we tell the beam's target to be a point on the character's spine, right, it will not automatically follow that point on the spine as the game continues to play.
So if I'm playing and I run away, it would just sort of be hanging out in
That's
space?
right. It's going to hang out with wherever that location was the moment the beam was brought to life. So what we need to do is make a system that kind of loops through and keeps updating that over and over and over. Now it's fairly easy to do. Here's our spawn emitter result, the return value. We're going to drag a wire from this and choose set beam target point, like so. And that's just going to set, of course, where that target's going to be, where our lightning's going to strike would be an easy way to look at that. Now to figure out where that location is going to be, we're going to start by getting our player. So we'll get our player character like so. So now we've got access to that. We're going to get the mesh. So we actually want the skeletal mesh. I want a location on the spine. To know the spine, I have to know the skeleton. To get the skeleton, I need the skeletal mesh.
Right. So basically follow that chain all the way down.
Yep. So let's just type mesh. And there's get mesh. Boom. Perfect. Now, we want a socket location or a bone location. Now, that is just one of those things that you should just know about. If we just type bone, there's get bone name, there's get socket bone name, etc., etc. But if you're looking for the location of a bone, you would actually use get socket location, because this works both with sockets and with bone names. It doesn't have to be a socket. So what we're going to type in here is spine 03. However, if you didn't know that for some reason, you're like, but I don't know what bone I want to use. You would need to grab your character and clear your filter. You would grab the skeletal mesh and you would open that up in Persona. Let me bring Persona back over so everybody can see it. And then, of course, you can check the skeletal hierarchy, and you can just click on things to figure out which one you want. Or we'll just go under Show, and we'll show the bone names, or show the bones. And there you go. And then if you also show bone names, you can see everybody's name. So spine 03, if I zoom in, there's some bones kind of stacked on top of one another, which makes that a little tricky to see. But spine 03 is kind of like right in the middle of the chest. So I think that's a good location for this guy to get struck by lightning. It'll be kind of like almost like an Iron Man thing. So we'll close that out, but it's important to note the spelling. Casing doesn't matter, but you want spine _ 03. So we don't really need electricity arc anymore. Let's go ahead and just save that and close it. We'll be making artistic tweaks to that later. Let's take our in-socket name, spine _ 03, like so. We now know that location, so we can feed that into the new target location, and everybody should be happy. Now, this is where things start to get fun. We now need to create a basic loop that will continue updating this target beam point as the character moves around. So that's easy to do. We could just make a network that just looped right back around and plugged right back to set target beam point. The thing is, I don't want that to run like infinite loop over and over and over and over again.
Right.
We have to be a little careful.
Yeah, I mean, you can only move so much every frame.
That's right. So what we're going to do is a sequence of events. So let's drag a wire out here and let's do a sequence. And the first thing we're actually going to do is essentially make a call to whatever our parent functionality is. The problem with doing it just exactly like I have here is this will, if I remember what you told me earlier before we started recording, this should immediately destroy the battery.
Right, and then it'd be done.
So it stands to reason then that we'd want to delay that. So let's just drag a wire off and we'll do a delay. And it's nice how that automatically gets wired in the middle. Now, the duration, how long are we going to wait before we destroy? The good news is we've already stored that as a variable. We have discharge time. So the length of that timeline will determine how long we wait before we destroy the battery, which is a kind of a nice, elegant way to handle this. In the meantime, we want this to loop back around and drive the target over and over, but as I mentioned, we don't want to do that on every single frame. So let's just create another delay. And 0.2, that'd be what, 5 times a second? Let's do 0.1, so that'll actually be 10 times a second, and we can tweak that. If you wanted it to be more or less, of course you could do that. As soon as that delay is completed, wrap that back around, and then re-trigger set beam target point. And that's just going to keep updating that target point to wherever the player moves around, so it'll seem like the lightning follows the character. If you do this and you notice that the lightning feels like it's lagging behind based on how fast you're moving, you would just want to take that delay and lower it so that it updates more often. Really though, in terms of the blueprint, we should be done. This should, if I'm not so much mistaken, be testable right now. So let's compile, let's save, let's drag this out of the way, let's go to our blueprints and grab our battery pickup, and we'll put it here on the floor and just kind of float it in the air. We can play from current camera location. And oh, we're here, looks good. Let's hit E. Oh, and it just disappeared. So not exactly what I wanted to have happen. So let's double check and figure out why that is. But something did happen, so that's good. So we spawned our emitter, we got over here. It looks like probably what's happening is our discharge time is actually not being populated. So that would be the next thing we'd want to make sure that we fixed. So let's see here. Discharge time. We should probably double check and make sure that this is firing the way it should. Of course, we could always watch the value over in the event graph, which is not a bad way to go about this. So if we right click, we can watch. Let's do, I'm trying to show things on the screen. Honestly, usually when I do this on my own, I've got a couple of monitors that I would use. But I'll make the most of my screen space real quick. And let's hit play. And we'd have to choose the actual battery pickup. So let's hit play here. And let's see, we need to F10.
That should have been done with our construction script though, right?
Yeah, and it's still set to 0. So we're not actually getting anything from that, which is not exactly what we're looking for. Okay, well, let's check over in the characters blueprint. We'll track this down. We will make this work. Because our goal here was to find some singular way to set the duration. So let's see. We have that duration. Let's see what happens if I just play this right now. So we'll play, and let's just choose my character.
Yeah, the timeline is going 1.5 seconds.
Yeah, the timeline's doing its thing, which is excellent. It looks like what we are not getting is...
Check back on the battery construction script.
Yeah. The only thing I can think of... Oh, no, I'm sorry. Battery construction script, obviously, is what you meant.
No, that's set.
Yeah, that's curious. So what I'm going to do is go ahead and we'll wrap this video up here, or we'll kind of pause things. And then when we get to the bottom of what's happening, we'll just come back and explain what we found.
Sounds good.